All right. Good morning, Santa Fe Indian School. This is Rich Schrader, and just honored to be here like usual because this is really the best school I get to work with in my career of working 27 years in schools. So it's an honor to be back here. Glad to be here with my Carlos Herrera, my colleague.
Good morning, Santa Fe Indian School. Hopefully you all doing well. It's a little bit exciting outside. We had a little moisture falling out of the sky, and so we're here this morning to talk to you guys about the sources of our water, why it's important, and to learn about ways that we can take care of and protect our water. I myself am from Cochiti Pueblo, so like many of you, grew up in similar places and had to learn ways of being a native as well as living in the outside world and becoming a scientist. So happy to be here to share with you guys about why our water is so important.
All right. So we're gonna share some slides, and we'll just jump right into it. All right. Well, the real content begins around just remembering what is a watershed, and a watershed is a place that helps determine how secure your water is, because it's the actual physical basin that drains water down into your rivers. And so you can have small rivers that contribute to larger rivers, but anything that somebody does inside these river areas will affect somebody downstream because the water will carry that pollution. And likewise, somebody upstream from you, if they do something that might impact your water quality, because they can destroy your the quality by adding pollution or doing something or using the land in a way that could cause pollution downstream for you. So we think about, what is your watershed address and what is the condition of the watershed, because that really affects you. And this is the entire watershed of the Rio Grande, and we're just in small basins that contribute to it. Here we are in Santa Fe. Um, and we want to know about the condition of the watershed because, water, as we've spoken, water is life. Water is given to us, and so we want to give back to the water so that we can make sure our 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 communities, both upstream and downstream, and our own community can survive. We want to have a good reciprocal relationship with the waters that sustain us, that are us. We're mostly water, and that we want to give back to those things that give to us. So we think about even a smaller watershed. Here's the watershed that the Santa Fe Indian School is located, and both Carlos and I live in here. And it gives you an idea where we did our field trips way up in the mountains last fall, up the Big Tesuque. And that was a place where there was pristine water. And then downstream, we have a place where we're going to be monitoring next week. Downstream, where the wastewater treatment plant comes here, just quickly to look at the hydrology of this watershed. It's about 68 square miles. The upstream area in purple is where we get our about half of our water supply, and there's reservoirs. It's off limit to the publics. This teal green line is going through the city, where essentially all the water that Santa Fe uses is running through our pipes. So there's no water in the river, but there's water in our pipes. And then about 60% of our water comes out in a wastewater treatment plant downstream, where it affects the pueblos of Cochiti, Santo Domingo, San Felipe, that are all downstream. So a couple things that are important to know. Here are some of your water policy and science keys that are important to understand. One is that pollutants are emerging. We don't, in wastewater, for instance, there's pharmaceutical products like caffeine and illegal drugs. Many are new to science that get into our water supply because if we consume these things, we ended up peeing them out. And so that's in our wastewater. And then there's some pollutants or stressors to our watersheds that when they get to a certain point, those concentrations or those elements can cross a threshold when bad conditions can be so hard to reverse. It's rarely ever done. And so it just polluted environment becomes the normal. For instance, some toxic materials last forever and should be used if possible. And so we have to be really careful and understand the condition of our watersheds, because we don't want to cross these thresholds where bad things happen, things die, or all of a sudden our whole land is starting to dry out. We also, reducing pollution and restoring water, you need to find leverage points, because in this exercise, this activity that we're doing, you're going to be asked to make a promotional, essentially a public service announcement about a new project. And so you can use education. You can do things like learn about your watershed, read the landscape, understand the land uses, where's some processes happening in the environment, even looking at ancestral ecological knowledge to solve some of these problems. And some people say dilution is the solution to pollution. That's been said for years. But sometimes you don't have enough water to dilute a pollutant. And you know, and pollutants are so concentrated, it's hard to dilute them. You need a lot of water. So that is one idea that people have put out there. It's still worthwhile to look at, but sometimes it's not possible. And then you need to think about, when you're observing pollution, are you observing it as a stressor, or how it's exposing things, or what is the response of the community to that pollutant? So those are all important ways to think about how you understand pollutants, and whether you're looking at it at the front end or actually at the tail end, and how things are responding to it. Another important thing is to understand there's many ways to measure water. We'll cover a couple of them here. One is this idea of an acre foot of water. Why is that important to know? Well, pretty much every Pueblo and tribe has some dedicated amount of water measured in acre feet. It's essentially 1 acre of land, which is like a football field, with out the end zones 1 foot deep. It equals 326,000 gallons. And if you don't use the water that's allocated to you for things like farming in acre feet, then you could potentially lose that water. In this state, at least, that's how it works. Know that 1,000 acre feet, which is quite a bit of water, is about the equal amount of 1.5 cubic feet per second, which is, if you look at that, that means it's about 10 gallons going by a point and every second for 365 days. Now, cubic foot is 12 inches by 12 inches by 12 inches going by every second. And then we have gallons, of course. Gallons, we often measure things like gallons. How many gallons of water do you use a day? And this graph kind of illustrates that. This is an interesting graph about the city of Santa Fe. You can notice the population has increased significantly over time between 1995 and 2020. But look at the water use in gallons per day per person has gone down from 168 gallons per day to 93. So, in fact, even as the population has increased, we're using less water now than we did about 30 years ago, which is interesting. And at the same time, Santa Fe is growing and the city is trying to secure more water. So we'll talk a little bit about what the city's trying to do. You can see in this yellow triangle right here, this is the expected gap in the amount of water that's needed by people and the water that is supplied. So the way the city is trying to deal with this in the long run is to get more water out of the Rio Grande. Right now, we get our water, about half of our water comes from the Rio Grande by being piped upstream from an area called Buckman. And that direct diversion out of the river takes up to about 6,000 acre feet. And it's what's very strange is if you look on the map on the left, the water that we're getting is actually coming from a totally different watershed that goes to the Colorado River. Here's a more detailed map, and it also shows us where we're monitoring. We're going to be monitoring downstream, but this dark blue pipe is the water supply pipe that exists now. This light blue pipe right here that's right next to it is the pipe that they want to build to take water from the wastewater treatment plant and pipe it back to the Rio Grande where they're taking water out now. If they can do that for every gallon they pipe back of treated wastewater, they can take out another gallon out of the Rio Grande. So that is their plan. It's now kind of mothballed. It's put on the back burner because now they realize they need to clean up and fix this plant, which is 60 years old and will take millions of dollars. And they're probably several years from even being able to have clean enough water that they think they can pipe back to the Rio Grande. This is the city of Santa Fe. So they're now trying to raise money to fix the treatment plant first. Right now, currently, that water goes downstream in a historic channel where we will be monitoring next week. So this is back to your activity. When you're thinking about your public service announcement or PSA, what that is you're releasing information to the public about how pollution can be reduced in the community. What's your plan? And you got to remember that you can look at how to solve these problems of pollution on the upstream side of the problem or the downstream. And you want to think about where you have the greatest impact to have improve these conditions. So for instance, one way would be on pharmaceutical products. Some cities have programs that once or twice a year, they have a big event with food and drinks, and they invite people to come down with their pharmaceutical products that they're not going to use. A lot of people, what they do is when they want to get rid of antidepressant pills that they're not going to use or some other pills, they just flush it down the toilet. Not a good idea because the wastewater treatment plant is not set up to clean that. So that would be an upstream solution. Okay, that's trying to deal with it before it gets into the water. A downstream solution would be something like regulating the Los Alamos National Labs for the bomb building activities that they're making, and they're using toxic chemicals, sometimes things like PCBs or even plutonium, and regulating them and saying, we're going to fine you if you pollute the river. You know, Cochiti Pueblo or Santo Domingo Pueblo could create water quality standards and say, we're monitoring, we detect this, then we're fining you. That would be that regulatory approach instead of education and voluntary approach, like with the pharmaceutical products example. That regulatory approach is a downstream solution. And sometimes those work and they can be very effective, but it's after the pollution's created and it's in the water. So here's just a couple links for you to take a look at about this wastewater return flow pipeline and the situation the city is in about the wastewater treatment plant being broken and essentially polluting the Santa Fe River. And as we look at the Santa Fe River, we look at this at some of the issues. We want to be able to study this. We know that they have been exceeding E. coli bacteria limits, which is potentially going to be something that could harm people that come in contact with the water if they don't take precautions, like washing up afterwards. In the past, those have been so high that it's too numerous to count. Students, we've been out there measuring phosphorus and nitrate levels that have been very high. And when you get very high nutrients, that ends up causing, if you look at this picture downstream, there's a lot of algae in that water, and that causes a whole other set of problems. So right now, the city's in this study and design phase, and they'll start, it will take millions of dollars to fix up this wastewater treatment plant, and it may take several years to start it. So with that, I'm going to pass this over to my colleague, Carlos, and he's going to go ahead and take over on this presentation. Carlos, I'll go ahead and share the screen again, and hopefully I will disappear in a minute when I pin you at pin. Okay, got it. Okay, here you go. I'm going to share this again and take it away, Carlos. Unfortunately, I can't see you.
All right. So as we're Talking about rivers, remember that what people do upstream have an impact on downstream users. What you're seeing here in the screen is one, I guess, body of water and structure that has really had an impact on the what's considered the Middle Rio Grande. The photo to the left over here is Cochiti Dam that has, well, number one, it was installed to help control floods throughout the Middle Rio Grande Valley. Those floods were having an impact on a lot of the downstream folks, including people in Cochiti, Santo Domingo, San Felipe, Santa Ana, and down into Albuquerque, and even further downstream to Belen. But installation of this dam really had an impact on our pueblo that we couldn't grow agriculture for many years. It also does things like remove sediment from the water, which causes further erosion as the river moves downstream. The other dam that you see to the right here is the Abiquiu Dam, which is responsible for holding and supplying water into the Rio Grande from the Chama River from the direct diversion project that Rich was talking about a little while ago. Abiquiu, just like Cochiti, is a man-made dam, and it's been said that the Chama River is more a water delivery system right now rather than a natural system. So go ahead and get the next slide, Rich. All right. So as we ask ourselves, what's happening in those rivers, and we start wondering about the management of our rivers, we ask ourselves, what do we do in order to assess and learn what's happening in our watershed? How can we go out there and make some observations that help us understand the health of our watershed? Number one, as scientists, one of our biggest things we do is we make observations. How do we make our observations? With our eyes, with our hands, with uh, gaining an understanding of what's outside. One way that we do that is looking at something that we call the chemistry, which will tell us the health of the water based off of different parameters such as turbidity, temperature, pH, total dissolved solids, and nutrients such as nitrogen and phosphorus. So, as we talk about turbidity, one of the biggest problems in the Rio Grande and rivers around New Mexico is how much sediment is in that water. That sediment oftentimes comes from processes such as erosion, and that can be detected on how much light is be able to pass through that water. If you look on the left, you'll notice that that water has very low turbidity. There is not much sediment or dirt in that water. And if you move to the right, that's what we consider high turbidity. Water temperature is also very important for fish and aquatic life. Cold water oftentimes holds more dissolved oxygen, which makes it easier for fish in order to breathe. If you want to go fishing for a trout or a very sensitive species of fish, such as a trout, you would oftentimes head to the higher mountains where the water is closer to the source of the water, which, of course, one of our major sources is snowpack. And as you move to those higher mountains, there is more shade, different types of food that the fish are able to eat, a lot of good oxygen, and great habitat for those fish in order to live. The lower rivers, like you might see down in the Rio Grande, oftentimes have more sediment, temperatures are warmer, and they're a lot wider, so you wouldn't expect to see such sensitive fish in those rivers. pH is another term that we talk about when we're talking about chemistry, which is a measure of acids and bases within our environment. You might not really understand what acids and bases are, but in school or maybe in Santa Esteban's chemistry class, maybe you guys have mixed baking soda and vinegar together to see a reaction. So one of those substances is an acid, the other one is a base. But as we're talking about pH, the scale goes from 0 to 14, with pure water being a 7 in the middle. If you want to see if your water's pure, if you test it, if it has a 7, it's good. One thing that affects pH within our environment is rainwater. Rainwater is what we consider acidic with a pH of 5.6. One easy way to remember that is acid rain. So normal water in New Mexico is normally at a range of 6.6 to 8.8, which is slightly basic. Another thing that we'll be looking at is something we call total dissolved solids. And oftentimes we're looking at how much salt is in the water. When you think about salt, think about the ocean. The ocean has a lot more dissolved salt than the fresh water that flows through our watersheds. But these salts can be oftentimes hard to detect. So, what we utilize is a TDS meter to measure how much salt is in there. Nutrients can also have an impact that oftentimes come from things such as animal waste or human waste, even. It can also be naturally occurring, but these nutrients are great food for plants. But it can too much of these nutrients can cause algae blooms, and when the algae dies, oxygen levels can be consumed by the organisms that are eating that algae, causing what we call an oxygen crash, and sometimes referred to as a term called eutrophication. Another thing that we're going to investigate when we're out there is the biology of the stream, which includes benthic macroinvertebrates, vegetation diversity, and the vegetation buffer width. Benthic macroinvertebrates are really the insects or bugs that live in the water. And by studying them, we can get an understanding of the health of the river, as some of these invertebrates are very sensitive. And if we find them in the river, it tells us that water quality is good. Some of the insects are less sensitive, and if we find those in there, that means that the river itself may be disturbed or polluted. These are some of my favorite things in order to examine on the field trip. Another thing, as we venture on our field trip, we'll notice that changes happen as you get near the water. You get a lot more trees and shading of the water. Those trees are beneficial because they do things like filter erosion or stabilize the bank. But overall, they improve habitat not only for humans and fish and birds, but 90% of organisms are dependent on river forests for a portion of their life. So that's why they're so important. And other physical things that we will be investigating include stream flow and discharge, the distance to a nearest disturbance, and we may investigate the rock embeddedness of the stream channel. Okay, so as stream flow, as you guys heard from Rich, is a way that we measure how much water is going past a point. In our field trip, we're going to ask you guys to estimate or calculate how many cubic feet per second of water are traveling down the Santa Fe River. And this may change throughout the day during the time when we're sampling. All right, so we are excited to get ready for our field trip with you all to the river. We do have some requirements when we go to the river. Number one is we ask you to wear some good shoes. And when I say good shoes, not your new pair of Nikes or a set of Crocs. We're asking you to wear a good second rate pair of shoes, your older shoes that you don't mind getting dirty. Make sure to come prepared with the jacket. This is spring in New Mexico, and at one moment it can be winter, and the next moment it can be summer. Just be prepared for being in the field. Make sure to bring a water bottle to keep yourself hydrated. And my number one rule is let's have fun, but let's also learn something when we're out there. So, Rich, you're muted.
All right, everybody. Thank you so much. It's great for you guys to get in here. I know you guys have a big day soon. You got a basketball game happening with the boys, and just want to say thank you. Just remember, one way to give back, be have good reciprocity in your relationships with water is to uh, understand the condition of it and find ways to improve it. And so, this is a great way for you to show leadership in your community using the science that you're learning in this program. So I want to thank you very much for the opportunity to work with you, and we'll see you soon next week.
See you on the field trip, guys. Have a good day.